Intensity of resultant wave. Intensity of resultant wave versus phase difference graph for interference pattern. Intensity of resultant wave versus phase difference graph for interference pattern. Now phase difference between two interfering light waves is phi, which is equal to 2n pi. For constructive interference, that means intensity becomes maximum, I tends to I max. And phase difference between two interfering light waves for destructive interference is phi, which is 2n minus 1 into pi, where I tends to I mean, and the value of n starts from 1, comma 2, comma 3, comma dot 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 dot. So here we can denote two axes, two mutually perpendicular axes. Vertical axis indicates the intensity of resultant wave, that is I. That means intensity of resultant wave I is plotted along vertical axis and phase difference phi is plotted along horizontal axis. This imaginary horizontal line indicates the maximum intensity of resultant wave in interference pattern. This is the maximum intensity of resultant wave. Now we can plot intensity of resultant wave for interference pattern with respect to phase difference between two interfering light waves. With respect to phase difference between two interfering light waves, we have to plot intensity of resultant wave with the phase difference between two interfering light waves. And here we can plot the graph of intensity of resultant wave. These are the different value of phase difference here, at which intensity of resultant wave will become maximum. We can denote the different values of phase difference, and intensity of resultant wave will change following this curve. Intensity of resultant wave of interference pattern will change following this type of curve, and intensity of resultant wave increases and decreases following this curve. And also on the left hand side, intensity increases or changes following this curve or graph. Now we can denote maximum and minimum intensity, or we can denote the different values of phase difference between two interfering light waves. At this point, phase difference between two interfering light waves is 0 degree. At the origin, phase difference is 0 degree. At this point means at the origin of the graph, phase difference is 0 degree. And for destructive interference, when we assume n equal to 1, then phase difference phi will be pi, and maximum intensity is I0. I0 is the maximum intensity of resultant wave in interference pattern, and intensity will be maximum at phase difference 0 degree, 2 pi, 4 pi, etc., and so on. And intensity becomes minimum at phase difference pi, 3 pi, and etc. So we can denote the different values of phase difference between two interfering light waves. And intensity of resultant wave in interference pattern will be maximum at phase difference 0 degree, 2 pi, 4 pi, 6 pi, dot 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 dot. And I is the intensity of a resultant light wave in interference pattern. I is the intensity of resultant light wave in interference pattern, and phi is the phase difference between two interfering light waves. Again, we can plot intensity of resultant wave with the phase difference between two light waves coming from two coherent sources, and they superimpose one another at a point in the medium. Along x-axis, path difference between two interfering light waves is plotted. Delta x is the path difference which is plotted along horizontal axis. And for constructive interference, path difference between two interfering light waves is delta x, which is equal to 2n lambda by 2. That means even multiple of lambda by 2, where n starts from 0, comma 1, comma 2, comma 3, comma dot 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 dot. And also for destructive interference, delta x is equal to n minus 1 lambda by 2, 2n minus 1 lambda by 2, where n starts from 1, comma 2, comma 3, comma dot 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 dot. Here path difference for destructive interference is odd multiple of lambda by 2, that is 2n minus 1 lambda by 2. And if n equal to 1, delta x is equal to lambda by 2. That means first dark fringe will be obtained at path difference lambda by 2. First bright fringe will be obtained at path difference 2 lambda by 2, and we can denote different values of path difference, that is lambda by 2, 2 lambda by 2, 3 lambda by 2, 4 lambda by 2, and on the left hand side it should be minus lambda by 2, minus 2 lambda by 2, minus 3 lambda by 2, minus 4 lambda by 2. So here we have plotted intensity of resultant wave in interference pattern with the path difference. With the path difference, and intensity changes with path difference following the curve as shown in the figure or as shown in the graph. And intensity of intensity of resultant wave in interference pattern becomes maximum at path difference 0 degree, at path difference 2 lambda by 2, then at path difference 4 lambda by 2, and also at path difference minus 2 lambda by 2 and minus 4 lambda by 2, and so on. And intensity of resultant wave will be minimum at path difference lambda by 2, at path difference 3 lambda by 2, at path difference 5 lambda by 2, and so on. That means if path difference is even multiple of wavelength or lambda, then intensity of resultant wave will be maximum, and intensity of resultant wave will be minimum at path difference uh, lambda by 2, 3 lambda by 2, then 5 lambda by 2, and so on. That means for destructive interference, path difference will be odd multiple of lambda by 2. That means odd multiple of uh, half of wavelength.